Assalamualaikum, my name is binti Naim and my metric number is AW180112.
Hi, my name is Nazira binti Makaha and my number metric is AW180077.
My name is Nur Ismailina binti Ismail. My metric number is AW180005.
Assalamualaikum and hi, my name is Siti Rabiatul Adwiyah binti Ishaq. My number metric is AW180056.
My name is Nur Syafiqah binti Abdul Halim. My metric number AW180165.
Assalamualaikum warahmatullahi wabarakatuh. Now, I will talk about the model steel Fink Truss roof. What if roof trusses and Fink trusses? Roof trusses, or also we known as truss rafter, are the most popular form of the truss framing, where it is providing a flexible, quicker installation and more affordable engineered solution for the roof. There are several types of the roof trusses, which is we have antique trusses, Fink trusses, hip trusses, mono trusses, raised tie trusses, and scissor trusses. For our project, we use Fink trusses. Okay, what is Fink trusses? Fink trusses is the most common type of the trusses used, especially on home and building. The trusses has an internal web configuration shape like W. Okay, this is a W shape, which it will give an ultimate strength to material ratio from span around 5 meter to 9 meter. This is the span length, which is cover the majority of domestic dwelling and which cover the majority domestic dwelling being built today. Steel as our why we choose steel as our material for our model. First, we found out that wooden trusses have several problems, which is wooden trusses did not last long as steel truss because of its wood material. Wood trusses also exposed to insect, which is in the long time it will get rot. Besides that, timber trusses also are likely to get damaged in extreme weather condition. And why we choose steel trusses. We choose steel trusses because we can use it for a longer time and it require a little maintenance. Steel trusses do not need chemical treatment to maintain its frame. For our project, we refer to the journal as our source. From that journal, we will design a truss based on the journal. This is the example of a journal that we designed the model in Microsoft ONENOTE. To draw the 2D model, we click the draw button and then we open the new file. We draw the button using tool. This is the tool to make truss shape, and then we fill it with color to make it more interesting. After we finish draw the truss, we insert the value, which is the load, the long span, the length of the span and the height using type toolbar. This is our design. We use Fink Truss that have 7 nodes. This is the node, which is we have 7 nodes, and the member, which is we have for the Fink Truss steel model. We use the truss that have 7 node and 11 member. This is the detail about the model. For the span long, we use 9 meter span, and then the height, which is 2.6, and then the degree in this section is 30 degree. The load of force that we put on the model is 2600 Newton.
Assalamualaikum and hi, my name is Siti Rabiatul Adwiyah binti Ishaq. My title group project is Steel Fink Truss Roof. This is my design, and the design have 7 nodes, 11 members. In nodes data, axis X and Y. For example, in nodes 1 is 0, 0. In nodes 2, 3, 0. At X 3 and at Y 0. And at node 3, X is 6 and Y is 0. And for example, at node 7, this X is 2 meter and 1. In the support spring table, we have K root, KY and KX. KY and KY have 2. It is nodes 1 and nodes 4 because nodes 1 and nodes 4 is end the triangle, end of truss. So 999 is support spring at XY at V truss, and is high value for support spring. Spring can support 99999 Newton, and at X is 1. So nodes 1 only at X can support at nodes 1. So for the input force, the load is at node 5, node 6 and node 7. The load is 2600 Newton or 2.6 K Newton. The output deflection is is we use the formula index deflect vector J28 is at this. So we use 1 and A5 is this nodes 1. So in the table member node and local fitness matrix, we must in the PDF and in page 15 is we use the formula F equal to K multiplied by D, where F is force vector, K is square fitness matrix of size n multiplied by n, and D is the resulting deflection vector.
Hi, Assalamualaikum. My name is Nur Nazira bintu Makaha. I will continue from my friend's part, which is I will explain about member data, output member parts, and table, which is health key assets, KEI, SI, SJ, YI, YJ, sign, and cost. First, I will explain about member data. As you can see here, for this box, there are 3 columns: member, INOTE, and JNOTE. In Fink Truss room, we have 11 members, and we have INOTE and JNOTE, which is we can see it from this figure. This is member number 1, member 2, member 3, 4, 5, 6, 7, 8, 9, and 10, and 11. And where is INOTE and JNOTE? You can see from this figure here. This is not 1, this is not 7, 6, 5, 4, 3, and 2. There are 7 not here. Okay, which is INOTE and JNOTE? This is INOTE, and this is JNOTE. Why? Because this is the name. This is member number 1. Member number 1, they have 2 nodes beside each other. First is INOTE and second is JNOTE. The INOTE is 1 and JNOTE is 7. Net, ASS, IZZ, EMOT, and UNILOAD. This all is input from the figure and we transfer it into the Excel. Net output member part. From here, for output member parts, we use this formula, which is we put data here, put data from here and here into the formula, and we get the value. For MVI, PSI, MJ, VJ, MPSJ, we use the same formula for all of this. Means we use the same formula for this part and this part, which is in that bracket member underscore first underscore result underscore vector, and we put the data and then we get the result. Net from this table, we need to use to calculate SI, SJ, YI, YJ first, because from this result we need to use it in LEN line. For SI, SJ, YI, and YJ, we use the same formula, but the difference is SI and SJ. For SI, we take the data from INOTE, and JNOTE is for SJ. Same goes to YI and YJ. The difference is the number at the end of formula. SI, SJ, we use 2, while YI and YJ, we use 3. After we get the value from SI, SJ, YI, and YJ, we can find the value for len. We use the square root formula and we take the data from SI, SJ, YI, YJ in the formula and we get the value. Net is KS and KEI. From this formula, we take the data mod in ASF and for KEI, we get the data from len, EMOT, and IZZ. After that, we can find the sign and cost. Sign is the data from II and YJ, while cost, we get the data from SI and SJ.
This is table local fitness and coordinate transformation matrix. This is table for T inverse. This is K local fitness matrix, and this table is T local to global coordinate transformation matrix. This table T inverse until member 1 until member 11, same as table K local and T local to global coordinate transformation matrix. So this is a table K local multiplied by T. So KT T inverse multiplied by K local multiplied by T. So this is table for KT local shift transformation to global distance and force. So for example, this is corresponding KT value is to be added. So for this value, negative 2505, this is corresponding KT value is to be added. This value is negative, so this value use formula equal MMULT E34, J39, AA34, and AF36. This is E34 until J39. So negative 2505. This is a corresponding KT value is to be added to row 3, column 21 of KT. This is 3 row 21 column. Add table matrix slash array cell number of assembly global. This is K. Position in local, F local fits in, F global fits in, and global force vector is applied load. So F local 0, D local 0, and F global force vector D from data D34 result for member 1 until member 11 as global display use the formula index deflect vector AHE global role. So F local display use A is K local multiplied by T and use data in global display. So for F local display fits N, formula global fits N, and F local display and the result. And this is the result from member 1 until member 11.
Next is K global, which is matrices. We can see here this is 21 times 21. And how we get the value for K global, we take the data from this support spring and input array cell number, array cell for assembly global K and KT. We put all this data into here. Don't forget about this too. And we enter and we get the data. It same goes to for all this column and row. We use the same formula as well. Next, K inverse. K inverse is the data from the previous, which is K global, and we inverse it. For example, this formula, we take the data from K global and we press the key, 3 keys, CTRL, shift and enter simultaneously. We press it at the same time, get the K inverse. Why? Because we want to get this one, this bracket. This bracket is show that is the K inverse. That is for FEM, not sum and deflection vector. For FEM, we take the data from this one, this and first vector. We take all this data and put in the FEM and we get the answer. For 9, we take this one for input force. We use the formula and we enter it to get the data. And for F sum, it is the sum from FEM and 9. Okay, for deflection vector, we get this one from the K inverse and F sum. That is plot note and member plot. Okay, we do this one. And for note 1 until 11, we recall it. We recall from the previous sheet to jump to the new sheet. So we use this formula. Same goes to I note and J note. We use the same formula to recall the data. For SI, SJ, YI, and YJ, we recall it too from the previous sheet. After that, we copy all this data and we put in design or chart to get the plot for our deflection plot. So this is our deflection plot and we get it like this one. SR or SL. Thank you.
Why we choose Fink Truss roof as our design? So, is the conclusion. Our group picked Fink Truss roof as our design because it is common design for the roof that used at the homes and pedestrian buildings. Fink design trusses are used today for pedestrian bridge and as roof trusses in building construction. The Fink Truss roof has an internal web configuration shaped like a W. To give the ultimate strength to material ratio for span from around 5 meter to 9 meter, and it is composed of several boards or steel bars that connect together to form an intersection at the top angle of the roof, like this. This truss and this design was provide the support for the rafters and give the roof its rigid designs and allow for several different types of roof lines while providing the strength and stability needed. Although in this project that we conduct, there are some error occur while we inserting the formula into the Microsoft Excel. However, to overcome this obstacle, we keep try and error, like we redo after a few times to get the better accuracy.